Hello, everyone, and welcome back. My name is Mr. Dean Cobalt, and today we are going to be talking again about measurements and significant figures. In my last video, I had talked about measurements and uncertainty, and at the end of the video, I was talking about how to figure out the significant figures or the measurement of certain measuring devices. I wanted to go over that a little bit more because there was not a lot of time at the end of the last video, and I think I was a little too quick. So I'm going to go over it again here with these three examples. So you can think of this as these two are two different graduated cylinders, and this is sort of like a smaller beaker. And so, how would you measure the significant figures? How would you read the measurement and report that in the proper number of significant figures that you're allowed? The rule is you're only allowed to estimate once. So you can only estimate one digit. So you're not allowed to estimate more than one. That would be reporting the wrong significant figures for the measurement. So in the last video here, again, the way you figure out the increment, what your increment value is you take two consecutive numbers on your device that are measured. So here I can take 3 and 4. So I can subtract the lower from the higher. So 4 minus 3. And so that's going to be mils. And then I divide by the number of spaces on the instrument. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I have 10 spaces, 10 increments. So I'm going to divide that by 10. So 4 minus 3 is 1. 1 divided by 10 gives me 0.1 milliliters. So that means that each line represents 0.1 milliliters. Okay, so if I know a line, that gives me an extra degree of certainty. So whatever the line is, that's certainty that I have for that element or for that measurement. So if I have my meniscus, so if my meniscus is like this, right? Let's make it a little bit better, right? Okay. And so here, here's my meniscus. And so I want to read what this is. So if it's 3 here, so that's this I know for sure, right? So 3, it's way above the 3. So I know it's 3 milliliters at least. So that is certain. That is known. And now I can figure out to what tenth that I know for sure here. So if I am at 3, then it's 3.1, 3.2, 3.3, 3.4, 3.5, 3.6, and I have 3.7. Now, if I'm looking at eye level and the meniscus, the bottom of the meniscus, if it looks like it's above the line here, right? So that would be 3.7. So then 3.7 would be known for sure. So it would be 3. I know that for sure. And then 0.7, I would know that for sure as well. Okay. So if it falls between the two lines, then I'm allowed to estimate one more. So if it's above the 0.7, then I know that. I can see that it's above the 7 or the 0.7, so I know these. So the 3 and the 7, I know for sure. That's certain. Now I get to estimate once, and that's when it's between the line. I can estimate once. And so I can kind of mentally divide this into 10, and I can say, okay, it looks like it's pretty close to the line, so I might say 7-1 or 7-2, right? So uh, let's say I say 7-1. So the last digit here, this last digit is my estimated digit. So that tells me when I report this, that's going to be, the uncertainty is going to be plus or minus 1 in that place of the digit. So since this is the hundredths place, it would be plus or minus 0.01. So you could go up 1, you can go down 1. That's what that means. So that's what I would report for my measure. Um, so if it's not written down, right? So if you don't have to report this, a lot of times you do. If it's not reported with the plus or minus 0.01, then it's usually assumed plus or minus 1 unless it's indicated otherwise. So if you're just looking at this and you know it's a measurement, then you can assume it's plus or minus whatever the last digit is, whatever place that digit is. Okay. Well, what if it's on the line? This is tricky. If it's on the line, right? A lot of students will get this get this wrong. Um, a lot of students, when they see it's on the line, they'll say, okay, 3 point. This is 3.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Oh, for me, look, it's on the line, so they'll write 3.7. It's on the line, 3.7, right? So however, the instrument allows you, in this case, we know that the instrument allows you one estimated digit, right? So you need to report that estimated digit. So if it's on the line for you, then that 7 is certain, right? Um, so you still are allowed to have that estimated digit. So if it's on the line, then you need to replace that with a 0 because you're allowed that degree of precision. So if you don't have the 0, then you're inadvertently telling whoever's reading your work that the instrument you used only had that degree of precision, but obviously it has more precision than this is indicating. So you want to make sure that you are presenting the precision correctly for your instrument. So if it's on the line, you got to have that 0 there. And then it's going to be plus or minus 0.01. So it's still one, different people can read it differently, so they can read it 1 up or one down. Okay, so that's the this instrument here. So now for the other instrument, this is important because then it's really important to follow the rule only one estimated digit. So if we follow the same thing here, then what we're going to do is we're going to subtract, let's say, 3 from 4 again. So 4 minus 3, that's milliliters again. So we have milliliters. And then this time we're going to count, again, we're going to count the spaces. And this time you'll see that we only have 5 spaces. 1, 2, 3, 4, 5. So we only have 5 increments here, 5 spaces. So when we divide by 5, we're going to get 1 again here. So 1 milliliter divided by 5, that's going to be 0.2 milliliters. So each line is now 0.2 milliliters. Okay. So what if, again, if our meniscus is like that, and you'll see that it is in between these two. So again, we're going to figure out our certain digits. So we have 3. 3 again is certain, so that's a certain digit, 3. And then we can do 3.2, 3.4, and 3.6. So we know 6 for sure. It's above 6. So and it's between 6 and 8, point 6 and point 8. So it's either 3.6, 3.8, or somewhere in between. Now here it looks like it's in between. If I read this in between, you might say, well, it could be 3.75, 3.85. You think you might be able to say that, like so, 3.75, right? But the problem with this is this 7 is between the two lines. So I'm estimating that 7. There's no line for 0.7 like I have for here. So if I don't have a line for it, then it's an estimation and I have to guess, right? So this would be an estimation, the 7, and the 5 would be an estimation as well. So that's 2 estimations. I'm not allowed 2. I'm only allowed 1. So because the 0.7 lies between 0.6 and 0.8, that 0.7 is my estimation. So I'm only allowed three choices here. I can either say it's 0.6, right? I can say it's 0.8, or if it's in between, I can only say it's 0.7. That's the degree of precision I'm only allowed. So in this case, if I would say it's 0.7. Now, if it's closer to 0.6, but not on the line, I still can only say 0.7. So there's going to be more inaccuracy or more imprecision, actually, in this instrument than in this instrument. Okay? So be careful of that. It's really important to know what your increments are, so that way you can figure out what you're allowed to estimate in here. And always remember, you can't estimate more than once. So that you got to be very careful with these instruments. If there's no 10 divisions, and if there's fewer than 10 divisions, and you got to be careful about how you estimate your last digit. Okay, last one is going to be regarding, let's say this is a small beaker. Same thing. I'm gonna figure out what my increments are. Well, obviously I don't need to figure out what they are here because there's no lines in between, and each line here is an increment of 10. So if my one space and the difference here is 10, 10 divided by 1 is going to be 10. So the increments here are 10. So again, here, if my meniscus, let's say this is my beaker. This is really narrow beaker, and so if my meniscus is like this, right? So it's here. I can mentally divide because this is the difference in 10. I can mentally kind of divide my space here into 10, and so I can estimate to the ones place here. So I know for sure that it's above 10 and it's below 20. So it's somewhere in between 10 and 20. So I know this for sure. I know that there's a 1 here because it's not at the 20 line. So I got this. I got the 10s. So now I'm able to estimate 1 place over. So I can estimate the ones place. So here I'm going to estimate, maybe it's a 7. So if I estimate 7, so it's 7 milliliters, and then that's going to be plus or minus 1 milliliter, right? So that's how you're supposed to figure out the significant figures of each measurement. So be careful about where you're estimating, and make sure you're only estimating once when you're looking at your particular instrument you're using to measure out liquids or whatever it is you're measuring now. Okay, thanks for joining me, and see you next time.